Good morning, boys and girls. Welcome to a marvelous Monday. And today we're going to get started on lesson 7, our hands-on with area and the distributive property. A couple things. Let's just remember perimeter. Perimeter, once again, was the area around. For instance, if Mrs. Swint said, what's my perimeter of my picture down here? It's around the outside. That's the measurement of a round side plus side plus side plus side. Now, if we're talking about area, we're talking about everything in the inside of Mrs. Swint's picture here. So area is the inside, perimeter is the outside. So today we're talking about the area, the inside, but we're also talking about the distributive property. Remember, distributed means to distribute the power. So I'm giving you a little bit, I'm giving you a little bit, and it makes the whole problem a little bit easier. So let's take a look at page 791. So turn your book to 791. And of course, before we get started, we need the joke for the day. So I pulled up some computer jokes and let's see what you think. The first joke is this. What did the spider do on the computer? It made a website. How about this one? What does a baby computer call his father? Data. Data. All right. So let's go ahead and let's begin on 791. The grid shows a rectangle with a length of 6 units and a width of 5 units. So we have our length with 6, our width with 5. If the length of this rectangle increases by 2 units, what would be the new area? Remember now, a unit is each one of these little squares. So let's go ahead. And the area of the rectangle is, so first let's figure out this area. Remember our magic formula, that area equaled length plus width. Length times width. So we have the length times the width. And if I had to write this in my problem, that would be my length of 6 times 5 equals, and I know all my friends are shouting out there, Mrs. Swint, we know that. That's easy. And you're right. It's 30 square units in this particular rectangle right now. So let's go ahead and shade more unit squares so that the length, which the length right now is 6, but we're going to make it into, we're going to shade it 2 more units. So we're going to now shade this in. So Mrs. Swint's going to do the best I can. I'm sure you guys are much better at this with your pencils or your colored pencils, whatever you're using. And now they want us to label the additional rectangle formed by what you shaded. Well, we started, right now, if I say our length we increased by 2. So now this is a length of 8 units. 6 plus 2 is 8. Our width remained the same of 5. If I went ahead and I created my math equation here, I'm writing down 8 times 5 equals, and all my friends know this one, 40 units. That's the new area. They're showing you on step 3 what we simply did, but they're showing you using the distributed property. Remember, we've got symbols. We've got the parentheses telling us what to do first. So I know I need to do what's in parentheses. We did 6 times 5, which was 30. We added 2 more units. So then this was 2 times 5, which gave us 10. We know then that 30 plus 10 is 40. And your area of rectangle B, or the new rectangle, is 40 square units. So we'll put that down there. Now, just by checking, we could simply do exactly what we did up here. 8 times 5, I've checked it. It's 40. I could count, skip count by 5, 10, 15, 20, 25, 30, 35, 40. Voila, I know I'm correct. Let's go ahead now to the next page. On the next page, we have guided practice or our try it. The distributed property can be used to model the area of a rectangle. Recall the distributed property allows you to decompose. So decomposing just means to separate, to partition it off. Using the distributed property to find the area of this rectangle, they want us to decompose one factor. So the 12, they're saying, hey, let's make this into a 10 and a 2. It's so much easier. We love our 10s. So let's go ahead. If you have a colored pencil, you could use it at this time to make it just a little easier. But what I'm going to do is I'm going to mark off 10. 1, 2, 3, 4, 5. This went lost count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which, whoops. Better erase that. That didn't look very good. And let's try it again. So I'm going to go all the way down here. Maybe. It's a Monday. We have to get everything to work right. Evidently, my marker's still in spring break time. There we go. So that would mark me to 12. And I'm just going to outline. But remember, we are talking area. So we're talking about everything in the inside here. Let's use black. And black we're going to represent as the 2. This section right here. All right, so what we're showing now is the distributed property. Instead of saying 12 times 7, I'm saying 7 times 10, which would give me a 70. And I'm saying the second rectangle here is 2 times 7 or 7 times 2, which is 14. And that makes it really easy to add because in my head, 70 plus 14, I know I've got 84. Now, for some of my friends, you probably already know that 12 times 7 is 84. But if you're not sure, remember in math, we don't want to guess anything. So let's go ahead and we want to make sure we always have our answers right. Down below in our talk about it, it says refer to the second activity, which this was our second activity. If you decompose 12 into 9 plus 3 instead of 10 plus 2, how would you have affected the results? Would it have been any different? And let's try it. So instead of saying, we could have said 9 times 7. That would have been one of ours in parentheses. And add 3 times 7. 3 times 7. So what we're going to see are my addition problem is going to look a little different now. It's going to look like this. We know 7 times 9. Anything with 9s, we can put down the 7th finger, and I know that, hey, that's 63. And then I would add 63 to 21 because 3 times 7 is 21. Add those two together, and voila, you're still going to get 84. It was a little more difficult, though, to add because it's much easier when we use our 10s. 10s are your best friend. Zeros are heroes. How can the distributed property help you find the area of rectangles with greater numbers? Well, what we did there was just 12 times 7. But let's say we would have numbers that are much greater, like 58 times 22. Well, 58, if I do 50 and I do 2 and distribute the power in that way, it'd be much easier. And so think of it outside the box of how you might use this distributed property. Let's practice it. It says use the distributed property to find the area of each rectangle. 7 units for my length, and we have 6 units for my width. They're separating the 7 into 5 and 2. You can simply multiply this, add them together. You guys got this. Let's go all the way down. They're showing you find the area of these 2 rectangles. I'm going to let you, I would like you to show me that you know how to do the distributed property. So kids, can you do this for me? On this particular one right here, I want you to definitely use the distributed property. Show it to me. You got plenty of white space over here. With this particular one, if you just want to simply show me, Mrs. Swint, I know 11 times 4, and here is my length times my width. Instead of doing a 10 times 4 and a 1 times 4, you can just show me the simple area with this one. This one, though, please show me the distributed property. I want to see parentheses. I want to see the operations of multiplication and addition. Let's turn the page. On the next page, we have our problem solving and our apply it. Julie is planting a garden, a vegetable garden in her rectangular, Julia is planting vegetables in her rectangular garden. Her garden has a length of 8 and a width of 12. Use the distributed property to figure out her area. I know all my information here, my length of 8. I have a width of 12. Go ahead, show me then 8. And I'm going to split the 12 up into, of course, 10 and 2, because they've done this so often. And I'm going to set this whole problem up for you. You could do it yourself, I'm sure of it. But just so you know what I'd like to see. And we're going to do 8 times 2. And Mrs. Swint, don't forget these parentheses. Equals. All right. Go ahead, and the number 8 is very similar. Number 9, describe 3 ways to find the area of a room with a length of 9 meters and a width of 4 meters. Not hard. Show me different ways you can split up the 9 and the 4. Remember, I want to basically see, and this is just your little hint, if 9 times 4 is for 30, and you boys know and girls know this is 36, maybe break this up into 5 times 4 and 4 times 4, or take the 9 and break it up into 6 and 3, however you want to do it. Down below, we have James. James needed to find the area of a rectangle with a length of 11 and a width of 9. His steps are to the right, so this is what he chose to do. Find his error. Well, it's pretty easy. Kept the 9 the same, and then he had 9 times 11, but I see a 10 and a 2. Share with me what his problem, what did he do wrong there? You're the teachers. How are the operations of addition and multiplication used when finding? Go ahead, tell me a little bit about that. Your homework's pretty straightforward. Neatness does count. Make sure I can read what you've done. Don't just give me an answer. Show me the formula. Show me your number sentence. That's very important. If I don't see it, I'm thinking you just said, hey, to your mom or dad or your brother or sister, what's 9 times 9? I want to see what you've done. Show me it. All right, my friends, we're done. Lesson 7 is completed. I hope you have a great Monday. We'll see you tomorrow. Take care.